Hey there, Mona Shore students, or whoever ends up watching this video eventually. My name is Mr. Lautenschlager, and you'll be seeing me quite frequently this trimester. This is our first lesson in Algebra 2. This is going to be considered Lesson 1-1, Part 1. So there'll be 3 separate videos. There's a Part 1, a Part 2, and a Part 3. And the current Part 1 that I'm going to talk about right now has 3 parts within it. The very first part that you see up on the board already and started is what's known as the order of operations part. Then there'll be a substitute and simplify according to the order of operations part, and then we'll conclude this with combining like terms. So that's kind of where we are. All right, so let's get started. You've, at least in me thinking, you've heard of the order of operations before. I mean, you're in Algebra 2, so this is not your first rodeo with this. I bet we've heard the expression, please excuse my dear Aunt Sally, which stands for parentheses, exponents, multiply, divide, addition, subtraction. You will notice I wrote the first letters up here. However, I wrote them as a list of 4. Because there's a common misconception when it comes to the order of operations. Some people think that there's 6 steps to the order of operations, like it's legitimately in the order that it says. You do all parentheses first, you do all exponents second, you do multiply third, you do divide fourth, you do addition fifth, you do subtraction sixth. That is not entirely true. Yes, you do parentheses first. So anything inside a parenthesis group, that's number 1. Number 2, anything that has an exponent, that happens. Here's where it differs. Multiplication and division happen at the same time, left to right. So if there's multiplication and division in the same question, you don't automatically do multiplication first. You do whatever comes first, left to right, in that situation. Addition and subtraction is then step 4 and approach the same way. You don't automatically do addition first, subtraction last. You do whichever comes first, left to right, if a problem has addition and subtraction in it both. So that'll take a little practice, especially if you've maybe heard that wrong or even been taught it wrong, which is unfortunate if that happened. So I have, let's see, 4 examples up on the board right now. We're going to start with those 4 examples, and then I have one more to wrap up this section. So as we look at example 1, and it says 3 plus 4 times 7. You know, if you haven't been in math in a while, or you're just not really, math's not your favorite thing, some people do it like you read a book and just read left to right and say 3 plus 4 is 7, and 7 times 7 is 49. No. There is no parenthesis, there are no exponents. We go right to the multiply divide step. There's a multiply. That's first. So drop the 3. 4 times 7 is 28. And this is how I'm going to expect you when things are done on paper or worksheets or whatever. I want to see the steps, and I'm going to outline my notes like I want you to outline your steps. So we did that multiplication first because it comes before addition, and then last, 3 plus 28 is 31. So that's that. The second problem, I've mixed in multiplication, addition, and subtraction all together. There are no parentheses, there are no exponents. So we don't have to worry about those. We go right to multiply divide. There's one multiplication right in the middle of the question. It gets done first. That means the 6 and the minus 8 drop down. So 6, 4 times 3 is 12, minus 8. Addition and subtraction are equal in when they get done. So when addition and subtraction are in the problem together, you do them left to right. So addition, subtraction, left to right. It just so happens that addition is on the left, subtraction's on the right. So we'll work this problem left to right now. So 6 plus 12 would be 18, minus 8, 18 minus 8, 10. So that's that. Okay, next question. We're mixing some things in. We're just going to work this right in order from the top. Number one, we do have parentheses. Whatever is inside those parentheses, we do them first, that being that. So, we will write 8 times, do the parentheses, 11 minus 3 is 8, plus 7 squared. See, each line of text is going to just have one operation done so that we kind of see the problem unfold. Next thing in order is exponents. There is an exponent right here. We do that next. So 8 times 8 plus 7 squared, meaning 7 times 7 is 49. We have multiplication and addition left in this question. Multiplication takes precedent next. 8 times 8, 64, plus 49. And then lastly, we need to do that addition, which is looking like, let's see, 13, 11, 113. Boy, let's hope I didn't mess that up already, huh? Looking 13, yeah. So there we go, 113. All right, last problem, until I just pause for a second and get example 5 up there. This one's not a whole lot different than the previous problem, just a little extra. So number one, we do have parentheses. Right there in the beginning, they go first. So 40 minus 4, that's 36. Divide by 6, minus 4 squared. Okay, next, any exponents that are there, take care of that. That's that. Now, please understand, don't call this a negative 4. That's a subtraction, so that gets done later in the question. We just look at this as 4 squared. So it's going to be 36. Divide 6 minus 4 squared is 16. Okay, we only have 2 things left in the question, which is division and subtraction. Next in order after exponents is multiplication or division. Whichever appears left or right, it's just division. So division's now. 36 divided by 6 is 6. 6 minus 16. This also brings something else into our lesson. This is the first time we're going to subtract or add or whatever and get a negative answer, which is okay. So we are doing subtraction last. 6 minus 16 is negative 10. Okay, I'm going to pause a minute and get the next example up there. Now, one thing you need to realize, and I need to remind myself as I'm making a video, if something went by quickly, you can always back this video up and look at it again, or pause it and look at something. That's the beauty of this. You don't ever have to feel like you're behind. So just, again, I'm going to pause a minute. Okay, so back at it. We got ourselves our final example of the order of operations piece. Now you can see this one's got a lot more stuff going on, and like I said, you can always pause this, write that question down, take your time. But question 5 has got both parentheses and brackets. Let me clarify, they're really both the same. Brackets are parentheses, parentheses are brackets. So we have what we have here is a parenthesis within a parenthesis. So we have to talk about that. So when we start with parentheses, in this particular question, we start within the big bracket, meaning all this stuff down here is going to be very much last. So start within the big bracket, and then everything inside the big bracket do according to the order of operations, like it's its own mini question. Inside the bracket, the first thing that takes precedent is this parenthesis. So that's the very first thing we'll do, so here we go. We'll leave the bracket. 10 minus 3 is 7, which will keep that exponent on there, times 2, and everything else stays the same. Still within that bracket, exponents are next. So 7 squared is 49, times 2, minus 13 minus 4 squared. Folks, I do understand there's an exponent down here, but remember right now we are working solely with inside this bracket until that's done, and then we'll reanalyze the question. So 49 times 2, that'll be 98 minus 13 minus 4 squared. Okay, so you see we took care of everything inside that bracket, and now we're just down to this basic problem. Within that bracket, or within the problem that's remaining, exponent takes precedent. So we'll have 98 minus 13 minus 4 squared. 4 times 4, 16. Okay, all that's left in this question is subtraction, and when there's multiple subtractions, it doesn't even matter if it was subtractions and additions. You do additions and subtractions left to right, which means we're going to do the first subtraction, 98 minus 13, which will be 85. And then we have to do 85 minus 16, which will be 69. So that's the end of that, people. That's kind of the end of how I'm going to talk about order of operations. You should be able to handle the questions within reason. Of course, there can always be questions, but you have, I think, enough to go by to do that. I'm going to pause now and then get the next set of examples ready. Okay, here we go, people. Now we're doing the second piece of part 1, which is substitute and evaluate. So please notice at the top here, I've said let x equal 5, y equals 2, m equals 7, and n equal 1/2. So you can see 3 expressions. This part's going to only have 3 examples for the substitute and evaluate. You are basically going to replace the variables with the values up here, and then you're going to use your order of operations to evaluate. So it's a continuation of the previous examples with a little added bit to do. When you substitute, you're going to have a couple of options, and that can get confusing. But like this says 6x plus 3y, which I hope we all know, and if we don't, here's a good reminder, that means 6 times x plus 3 times y. What I'm talking about the substitution is you can just use a times sign if you want, and then replace the x with the number, like this time it's going to be 5. And sometimes when people substitute, they use parentheses to substitute. I'll kind of show you both ways. For example, one way I could write this problem right here is 6 times x value is 5 plus 3 times the y value is 2. And to some people that will be very comfortable and they'll like that. And then according to order of operations, which you have from the previous video and you should have right in your notes in front of you now, multiplication takes precedent over addition. We don't just do this problem left to right as it is. The 2 multiplies happen left to right. Addition happens lastly. So 6 times 5 is 30. 3 times 2 is 6. 30 plus 6, 36. Now, I'm not going to totally entirely redo this question, but there are times when you're replacing a variable, it's nice to use parentheses, and what I mean is like this. And that would mean exactly the same thing. It doesn't mean, it's not like you're saying, oh, wait a minute now, order of operations, you have parentheses included now. Parentheses in the order of operations means if there's something inside of them to do, do it. There's nothing inside of these parentheses to do. There's a single number sitting there. There's no operation like addition, subtraction, multiply to do. So 6 times 5, 30, 3 times 2, 6, 36. It's one of those things that's got to be what you're comfortable with. And then you have to realize that I'm not going to do both every example I do, so you're just going to also have to kind of roll with it. Okay, next one is very similar. 2m minus 3x. That's 2 times m minus 3 times x. Substituting those numbers in. So we'll do 2, m is 7. I'm doing the parenthesis version this time, minus 3, x is 5. So that's sometimes how I will write it instead of the times signs that I originally did in the question 1. Multiplication takes precedent over subtraction, so multiplications happen right now, left to right. 2 times 7 is 14, minus 3 times 5 is 15. 14 minus 15, negative 1. Okay, lastly, here's an example because there are parentheses in the existing question. Here's where maybe this method would not be as preferred, using that. It would maybe be better if we go back to the original way I had this question written, which was like that. So sometimes using those time signs, it has to be kind of a situation like, hey, what fits best here? So we have a couple of variables to substitute for, and that's what we're going to do. So let me do that first. So 4, 2 times x, which is a 5, plus 8 divided by 10 times n. So 10 times 1/2. So there's our original problem, technically, when you say it. There's the order of operations. Now, I want to address something here that's very important that seems to happen year after year after year. When you have nothing but numbers plugged in, this is all numbers, all order of operations now. Never in the order of operations do you do what's known as the distributive property. See, the first step in order of operations is parentheses. So whatever's inside the parentheses you do. I've seen people distribute the 4 here. It will lead to wrong answers because you're partially doing multiplication before you do the parenthesis work that you're supposed to do. I'll explain the whole distributive property in the next little segment, but right now, we go inside the first set of parentheses. See, there's 2 sets of parentheses, so we work them left to right. Inside the first set of parentheses, multiplication takes precedence. So we got ourselves a 4 right here. 2 times 5 is a 10, plus 8 divided by 10 times 1/2. And I am breaking this down little by little, so here we go. Next thing, inside the parentheses, this parentheses first, finish the addition. So 4, 10 plus 8 is 18, divided by 10 times 1/2. We now take care of the second set of parentheses, which is here, just doing 10 times 1/2. Please understand 10 times 1/2 is 5. So we will have 4 times 18 divided by 10 times 1/2 is 5. Here's the problem we have left. And I know I still have the parentheses here from previous, but there's nothing inside them to do. These mean multiplication. So you guys, we have multiplication and division left in this question. When they are both present at the same time, we do them left to right. So we do this multiplication first, which will be 72 divided by 5. Okay, so we got ourselves a weird situation here. This might be a time, and there's a couple of other times where you're like, I might have to use a calculator because I don't know everything in my head. Like I might not have known 4 times 18 is 72. But this is going to be a decimal. So let's think about this for a minute. 5 will go in once with 2, 4 with 2. So it's going to be 14.4. Also known as 14 2/5. So, yeah, that's that. All right. So, you guys, that's just a continuation of the last little section. With the added, maybe added difficulty, just an added step of plug a number in correctly and then do order of operations. Okay? Pause again. Gonna get ready to finish the last section of this. Okay, everyone, let's close out section 1-1, part 1. The last thing to talk about in this section is what's known as combining like terms. And you might look at some of these problems right here that are in front of you and say, hey, wait a minute, these look kind of similar to the problems you did in the section previous. Here's the difference. One, I kept all the letters the same within the question, which doesn't have to happen. But secondly, there's not a thing that says, hey, let x equal. You are not substituting a number in simplifying. You are simplifying it based on what are like terms. Let's understand something. Things that have the exact same letter with the exact same exponent, that's a key part right there, are considered like terms, which means x's are like other x's, x squares are like other x squares, x cubes are like other x cubes. X squared is not like term to x. X squared is not like term to x cubed. So we'll see that as we go. And it doesn't matter what's sitting next to each other or not. If they're a like term within the problem, we add and or subtract the problem, and I'll clarify as we go. So number 1 here, we have this 12x plus 5 plus 3x minus 2. I basically start with my letters first, and if there's more than one type exponent, like number 5 over here when we get there, I start with the higher exponent thing first. Well, all we got is x here. Now, when you go to combine your x's, you read the sign in front of the term, meaning the x's are 12x, read that sign, plus 3x. So 12x plus 3x is 15x. It's not 15x squared. That would be multiplication. X times x is x squared. We're just saying, that's like saying I got 12 apples and I'm adding 3 apples to it. Oh, I got 15 apples. Name doesn't change. Now, the numbers in the problem, those are like terms, just basic numbers, no attachment to a variable. That is a positive 5. See, the sign in front dictates what you do. Minus a 2. 5 minus a 2, that's 3, positive 3. And that's all you can do in terms of like terms. You can't say that says 15 plus 3, that's 18. No, that's 15 x's plus the number 2, or plus the number 3, excuse me. So, end of problem. Okay, question 2 introduces parentheses. Now, similarly to order of operations, parentheses kind of get your attention quickly. Here's the difference. Inside the parentheses, I can't do anything. You say, well, there's a subtraction there, but it's 1 minus 3x. It's not like term subtraction. Here's where the distributive property comes into play. When there's variables involved that I can't combine, I have to do the distributive property. So I am going to, as we call it, distribute the 7, multiply the 7. The negative 4 is a non-issue right now. So here's how I read this. I read this as 7 times 1, which is 7, positive 7. And then I read this as 7 times minus 3x, which is minus 21x. That's where I have to do the distributive property, and it works. In the previous section, in the section before that, parentheses had nothing but numbers inside, so I had to do the operations. No distributive property in the order of operations, only when there's variables involved. Lastly, the only like terms that I have is this negative 4 plus 7, which is 3, minus 21x. You can leave the problem like that. I'm fine with that. I know there are some picky people, like depending on if you get to a college level class, they might expect the answer to have the variable leading off, which would be negative 21x plus 3. Please understand that these are equivalent answers, that the minus is attached to the 21, so minus 21x plus 3 is equivalent. Okay, moving on to number 3, not a lot different. You have a parenthesis. Inside the parenthesis is subtraction, but it's unlike term subtraction, so I can't do it, hence the distributive property. So 9x distribute hence multiply. Positive 10 times 6x is positive 60x. 10 times minus 1 is minus 10. The x's are like terms. Now see, I got rid of the distributive property, and now I combine starting with the x's. 9 plus 60 is 69x minus 10. Done. Those are not like terms. I cannot subtract those. Down here, I have two sets of parentheses. So I am going to immediately start with distributive because, again, inside the parentheses are not like terms. So I have to distribute, and I've made this a certain way so you understand. Now, you just distribute the parentheses left to right. So starting here, we're going to do this multiplication, negative 9 times 6x, which is negative 54x. Be careful here, people, with your sign. That needs to be interpreted as negative 9 times negative 3, which is positive 27. And then I want to talk about this. A minus in front of a set of parentheses is like distributing a negative 1. It's like saying times negative 1. In other words, it's like change the sign. So when I say minus to that, it's minus 1. When I say minus to that, it's minus 4x. So when a minus distributes to the parenthesis, it basically changes the sign because that's what times negative 1 does to a sign, or to a number. It changes the sign. We are done with parentheses. Now we just combine like terms. Our x's first. That's negative 54x minus 4x. That's minus 58x. Our numbers are positive 27 minus 1. That's 26. Positive 26. And that's that. Okay? Last problem. The last problem, I have taken out parentheses, but I have put in different kinds of x's and numbers mixed together just to kind of get that idea covered. So this one, we just have one long expression to deal with. As I said at the beginning of this segment, if there are multiple of the same letter with different exponents, start with the biggest exponent. Folks, our biggest exponent is 2. So right now we're going to take care of all the x squares in one shot. Just to kind of focus on them a minute so that I don't miss one. There they are. So x squared y's, I would say 5 minus 8, which is negative 3. Negative 3 plus 5, which is 2. That's 2x on the squares. And sometimes when I have so many things I'm looking at, because down here I was only looking at like 4 things, I'm looking at a big string of things, so get those out of my way. Next thing I will look at after the x squares is the x's. I treat this as negative 6, minus 3, which is negative 9, plus 11. Negative 9 plus 11 is 2, positive 2x. Total coincidence there. Cross those off to get those out of my way. And if I kind of then take inventory, the only thing that's left here, folks, is the minus 12 plus 4. Basic numbers, no variable. Negative 12 plus 4 is negative 8. All right, folks, so that concludes lesson 1.1, part 1. This is a 3-day lesson. Well, things are going to be different. I'll explain that later. But this would normally be, we spend 3 days on 1.1 or 3 class periods. So we'll talk about that in person a little bit. But there's the first one. All right, take care, everyone.